In this video we're going to talk again about simultaneous equations and how to solve them algebraically, i.e. not graphically, but we're going to use another method which is called the method of addition. And let's take an example to show how we do that. So solve. Let's say we have to solve the following system of equations. 2x plus 3y equals 16. Plus 3y equals 16. And 4x minus 3y equals 14. 4x minus 3y equals 14, and they're in the same system, so we put the curly bracket around it. This is equation 1, this is equation 2. So we have to solve this using the method of addition. Now the method of addition is quite fancy, because what it means is you can, if you have a set of simultaneous equations, you can actually add up the left-hand sides of the this equation. So we can add left-hand sides, and we can also add right-hand sides, keeping the equal sign in the middle. Sometimes that helps us because let's just do that and see what happens. Well, we have to add 2x to 4x, which gives me 6x. Then I have to add 3y to minus 3y. Plus 3y minus 3y makes 0. And then 16 plus 14 on the right-hand side makes 30. So by adding the left-hand sides, I have got rid of the y's. The 3y has cancelled with the minus 3y. So I have another equation, but in only x now. So I have 6x equals 30, therefore x equals 5. 5 6s are 30. And knowing what x is, I can then put it in either equation 2 or equation 1 and find y. So substitute x equals 5 into 1, for example. I get 2 times 5 plus 3y equals 16. So 10 plus 3y equals 16. Move over the 10 gives me 3y equals 6 and y equals 2. So the solution is x equals 5 and y equals 2. Sometimes, however, we don't have a term which exactly cancels out. So we have to maybe multiply by a factor, multiply the whole of one or both equations by a factor so that one of the variables cancels. Let's try an example. So we're told to solve let's try this equation here. 2x plus 5y equals 41. 2x plus 5y equals 41. That's our equation 1, and 3x plus 8y equals 65. 3x plus 8y equals 65. Solve this using, that's equation 2, using the method of addition. Sometimes you're not told which method to use, and you can use a method of your choice. But in this example, I want us to use the method of addition. So if we look at this, I have 2x on the left hand side of equation 1 and 3x on the left hand side of equation 2. They don't cancel out. Let's look at the y's. I have a plus 5y and a plus 8y. If I were to add them together, they don't cancel out. So I have to do something to both the equations in order for either the x's or the y to cancel. And I would normally recommend you to work with the smallest of the factors, because then that will give you, then it means you'll be multiplying by smaller numbers. So what happens if I multiply all of the terms in equation 1 by negative 3, at the same time multiplying the terms in equation 2 by 2. Let's see what happens. So 2 times minus 3 makes minus 6x. 5 times minus 3 is minus 15y. And then 41 times minus 3 is minus 123. Big numbers now. Let's multiply the second equation by 2. I get 3x times 2, which is 6x, plus 8y times 2, which is plus 16y, and then 65 times by 2 is 130. Just make that a bit clearer. Now, after this multiplication, you can see that I have a minus 6x here and a plus 6x here, which will exactly cancel. So now I will add left hand side and right hand sides. Respectively. And that will give me minus 6x plus 6x is 0. Minus 15y plus 16y gives me only 1y left. Minus 123 plus 130 gives me plus 7. So y is 7. That was nice and easy. And then to find the x, I can just take that y and put it back in either 1 or 2. So 2x plus 5 times 7 equals 41. 2x plus 7 5s are 35 equals 41. 2x equals 41 minus 35, which is 6. Therefore, x equals 3. So the solution to this one is x equals 3, y equals 7.